Hi everyone. Welcome to our second video in the Why Does It Work series. This time looking at multi-digit subtraction, or sometimes known as long subtraction. This series, as I've mentioned in the previous video, is about taking a look at procedural approaches to mathematics, in this case, of course, subtraction, and then taking a look at why they work. It's not a case of removing these or stopping students from using procedural approaches. What the issue is that if students use these approaches without understanding the mathematics behind them, it leaves them open to lots and lots of errors. And so the purpose of this series is to help you understand the mathematics behind these common procedures, so that you can help students build understanding, not only in a way that connects them to what they already know, but also supports them for what comes next. And often missing the conceptual understanding behind a procedure in a younger grade doesn't show up in terms of affecting their performance until a much later grade. And so, for example, what I'm going to show you today with subtraction relates almost directly to integers in junior high school. So the operation we're going to take a look at is 123 minus 45. Now you guys are familiar with the standard procedure for doing this. I would start on the right hand side and I would try to take the 5 away from the 3. I can't do that, so what I would then do, and the magic word is borrow, I'm going to borrow 10 from the tens place here. Quite often I would say I would borrow the 1 from the 2, leaving a 1 behind, and I would use that here to make the 3 a 13. Better to say, though, that I'm borrowing a 10 from the 20 and leaving 10, and this remains as 13. Now I'm going to subtract the digits on the right-hand side. So 5 from 13 is 8. So far, so good. I'm going to repeat for the next place value. So I'm going to borrow from the 1, leaving 0. Borrow from the borrow from the 1, leaving 0. The 1 becomes a 10 here, so the 1 becomes 11. 4 minus 11 is 7. And I just repeat that process over and over again until I've got all of my digits run through. Now, this will give you the right answer. And if you're strong with memorizing steps or recipes, you can probably repeat it in a whole pile of situations. The problem is understanding why it works, because there's a lot of mathematics and a lot of key concepts hidden inside this that get missed if all we teach is a procedure. This can show up in later grades in terms of missing the conceptual understanding that underpins future understandings, but it can also, just in the short term, reduce the student's ability to spot a mistake, or even just to spot when an answer is unreasonable. So let's take a look at a different way of doing this. So if I take my base 10 blocks out, I can represent the numbers 123 and 45. So you can see here I've represented 123 with a single 100, a couple of 10s making 20, and 3 1s representing 3. Likewise, with the 45, I can have 4 sticks, which makes the 40, and I can have the 5 units representing the 5. Now, even though that's correct, it's also important for the kids to be able to represent those in different ways. So, for example, I don't have to represent the 100, 2 10s, and 3 1s. I could actually do 100, 1 10, and 13 1s. It means exactly the same thing. 3 10s and 15 1s means exactly the same thing. I could have 123 1s. That would represent the same thing. 12 10s and 3 1s. Lots of different ways to represent this. And it's important to get your kids to play with these and to represent these numbers in as many ways as possible. And the reason for that is that this is going to help to build their understanding of the associative property. And what the associative property says is that no matter how I regroup these numbers, it doesn't change the final answer from that subtraction. It doesn't change the value by simply regrouping, and that's called the associative property. All right, well, let's look at what the operation kind of looks like before we get into the big numbers. We'll do this with some small numbers. And really the rule of this game is we're going to remove matching pieces. So if I had all ones up top and I had all ones down bottom, then really what I want to do is take the 5 ones from the bottom and take the 5 ones from the top. Of course, in this situation, I can't because one of those is a stick, but that's not a problem. Let's keep going. So I'm going to match all of my subtrahends. Those are these guys down here, the ones that we're subtracting. And we're going to remove them, the same number, from the matching minuend. Minuend being the number being subtracted from. So I can take 2 out of the bottom and I can take 2 out of the top. And sure enough, what that gives me is 10 minus 3. And what we've just done, because we subtracted from the top and the bottom, we can say that 12 minus 5 is now 10 minus 3. And that's an important concept. That's known as compensation. The idea that when I subtract something from the minuend and then subtract the same thing from the subtrahend, I don't change the meaning of the expression. All right, so let's continue this. So I have a 10 stick. I can't cross these out anymore because the 10 is kind of glued together as one stick. But that's no problem because I can just take that 10, throw it back in the box, and take 10 ones out instead. And now I can use that regrouped set, and I can start removing from both the minuend and the addend, applying that compensation strategy. And so now that I've removed from both, I can see that my 10 minus 3 is now 0 down here, and 1, 2, 3, 4, 5, 6, 7 up here. There's our answer of 7. Now that might seem overly complicated for what we're doing with simply 12 minus 5, but let's take a look at our 123 minus 45 again. So for this example, I'm just going to try and match up operations. I am choosing to write it as the 100, the 20, and the 3 using my place values, but I don't have to. I can rearrange these any way that I want as long as I don't change the overall number. I am going to take the 5 from the 3 in this case. I'm going to try and match a minuend of 3 to a subtrahend of 5. I can't do that directly, but I can actually take one of those sticks and break it up, trade it for another 10. And now I've got 10 units up here, and I've got 5 units down here, or sorry, 13 units up here, 5 units down here. And just like before, I can remove from both the subtrahend and the minuend, and what's left is just these 8 units. Now, already you can start to see what's actually happening when we're talking borrowing. But the other thing is that my operation here is incomplete. 123 minus 45 is definitely not 8. But I can still see the rest of the operations sitting in this larger group. Okay, we can continue with the same step. I can actually take that 100 block and I can trade it for 10 tens, which I've done here. And that's effectively what's happening when I take this 100 block and trade it for 10 tens. Again, I've got 11 tens. There's my 11. I've got 4 tens on my subtrahend, which is my 4 down here. And just like before, I can get rid of 4 from the minuend, 4 from the subtrahend, leaving me with 7 overall. And at that point, I'm actually out of red tiles, and so I know that I'm done. And so what do I have left? Well, I have 70 units, or 70 tens, I should say, and 8 units, which means my final answer is 78. Again, this is more efficient, and I'm not saying that it's not, but doing this without understanding that this is what's going on behind can be dangerous. And one of the reasons that it's dangerous is when we get into integers in junior high, we'll start actually referring to these as positive tens and negative tens, and positive ones and negative ones. And unless that we have this understanding of the compensation strategy, then when we start talking about what are referred to as zero pairs, which is essentially a rephrasing of the compensation strategy, that if I take this minuend and the subtrahend and put them together, they add up to 0. And so they don't count, so I can get rid of the block. Now again, I started from right to left in this just because I wanted to match it up with my standard procedure. However, it's really important to note that I can do this in any order. I could actually pair up my tens and all the ones that I've got before I even start the operation. And so that changes my operation from 123 minus 45 to 100, because there's just the 1, 0, 10, 0, 1s, minus 2 10s, 2 1s, 22. I can also, and this is far less efficient, but I can also take all of my blocks for the subtrahend and I can trade them all for units. Might look like a bit of a mess, but it is solvable, and I can start just taking one at a time and pairing them up and pulling them out. Again, the intent of both of these is to first understand, then move to efficiency. So by all means, please don't think that I'm asking you not to teach a standard procedure. But what I am asking you is please make sure that you wait until the students understand with the base 10 blocks what's actually happening and can model the operation before you show the shortcut which represents that operation. And even then, making sure that the student understands what is actually going on and matching that up with the base 10 blocks. As always, if you have questions, give me a shout, and I hope this is useful.